Hey guys, it's Damien here. After I've released the parts on Thingiverse and Printables that are now available, I have not been able to replace these components that are prototype components with the ones that I've released. So I have them all right here, and we'll be able to put that together in replace of these and install new hardware, as well as some tips and tricks on the things I've done to make sure these prints come out well on your 3D printer. So here are all the parts that you get from Printables or Thingiverse. The one thing that's not showing is this custom tray if you wanted to fly the Hyperior batteries, but that will not be part of this video. Now, what I recommend you guys buy if you are printing these out and trying to put this together is these self-tapping screws. I will do my best to link the Amazon link for this in the description below, but these are pretty much self-tapping screws that will be able to hold these plastic components together a lot better. And if you do not want to be stripping your screws, I got myself a Strabito screw set that comes with all these really nice, very fine Phillips and flathead or whatever screw set heads, but we're pretty much going to be using a 0 and a 1. PH1 I believe it is, and then a PH0 for majority of these screws. I even printed out a tray yesterday just to put all these screws in here. So I will tell you which exact size I will be using for all these components. So let's get started. I will also eventually show you guys how to form this in this video as well. Now to print these out, let's go back to this. I pretty much printed this landing skid flat because it increases the strength, because when it's printing like this, back and forth. But if I were to have it upright, then it would print parallel to the ground, and that would actually make the print weaker. So that is why these are flat, and maybe one of these days I'll try to test out a print with them angled up, but as of right now, that's how these are formed. All these parts are pretty much printed at 0.1 millimeters as far as the resolution goes, just because these parts are very tiny, and to be able to get the exact tolerances that you're looking for can be really hard when you're printing at 0.2. So all these parts are 0.1 millimeters. Now the boom block, you could tell I put a split right down the block right there, so it will tighten up the boom, and it just prints out upright like this with no supports and no supports on that hole. So as long, whatever orientation you want, as long as the opening is pointed upward, you could easily print that, no problem. Same thing with the battery tray. I kind of print it flat and no problems there. The anti-rotation bracket also is printed flat with no supports. It's a very simple print. Now, as far as the flight controller tray, I actually have it upside down, and I have a little bit of supports because I cut these out so that there might be some spring to it. I'm not too sure, but to decrease the amount of material I used, to decrease the amount of material, I pretty much cut a section of these out, but it's just a way to make sure you have some sort of flex, and I actually feel the flex in these. But yeah, pretty much print it flat and you will have no problem there. I combined both components for the vertical stabilizer. Usually there's two pieces, but I mated these together so that you have less parts to think about when printing. So this is also printed flat. As far as the motor mount, I actually forgot for this specific part to put some supports in here, but I usually put a little bit of support in each of those holes, print it flat, and they tend to just pop right out. All these components, as far as the frames go, you might be able to tell in this video, but there's some lining that you could see when it's printing flat on the bed. So I just orient it where the surface finish of the top layer is printed upwards. So I do have a left and right piece, but it really doesn't matter. It's kind of hard to tell. Same thing with the bottom frames here. And then the frame adapter is pretty straightforward and simple. You just plop them on there with the holes facing up. And then the tail boom. So there is a small trick, a couple tricks that I have done before to make this a successful print. Usually the first layer when you're printing is a lot thicker, but for this entire print I had the first layer all the way to the last layer at 0.1 resolution. Usually when you're printing, it prints a thicker layer on the bottom, and then it'll start to print in that lower or higher resolution. But because when I first did that, it made this bottom layer super thick, and it just didn't fit too well in the tail boom block. But as far as printing this from the bottom up, no brim, no skirt, nothing. Pretty much a brim is, it has a few layers that attaches on the bottom surface of your print to make sure it stays on the bed, but I don't really have any adhesion issues. As also, there is one hole that's the setting hole for the tail boom block you see here, and when I'm printing this tail boom, I make sure that this top part of the boom is actually printed on the bottom, so it doesn't have to struggle as far as printing a hole on the top layer. So orientating this, I pretty much print it with the top of the tail boom on the bottom of the bed and with no supports. And believe it or not, yeah, no supports in that tail boom. I added that piece inside the tail boom just so that it can hold the screws. Usually there is an inner piece in that tail boom so that the screws going through the vertical stabilizer into the tail boom hold. So instead I also included that in the tail boom, so there's less pieces to worry about during assembly. So let's just get started. As far as printing, I'm sorry, as far as building, goodness, I've constantly been thinking about printing this entire time. So, all right, we'll start with this. Actually, no, we will start, usually I start with the top of the frames, and here are my screws, and I am going to be starting off with a pH 0. Now, as far as the screws go, I will just go through them very quickly, but I'll probably repeat them in the video. From left to right, they're small screws to the biggest screws. This first section here is a M1.4 by 6. These are the flight controller tray screws. These are the top frame and the adapter screws. Those are M1.5 by 3s. This next section here is a M1.5 by 4, and those screws are specifically for the battery tray, the motor mount, and the top left and top right boom block. So I tried to make sure that the screws are matching very closely to the screws that come with the kit as far as size goes. So these top ones here are the M1.5 by 4s. Now for the vertical stabilizer, I have a M1.5 by 5. These center ones here are M1.7 by 5 for the landing gear. The anti-rotation bracket is M1.7 by 6. And these last two also go to the tail boom block. One side is specifically to hold on to the frame, which are the shorter ones. They are M2 by 4s, and then these long ones are M2 by 12s. And as I mentioned earlier, I'm not making any money on this, but these are the screw sets that you want. All the screws that I've mentioned are in that kit. All right, now let's start putting this frame together. So when you're putting this together, you want to make sure that the point of this is similar to the point of that frame. And I always get confused on this, but you want to start off with the screws on the back side. These holes are the same exact holes that you will be using in your prints for the hardware that comes with the kit itself, and they will be small so that it's going to be a lot harder to put this together with the hardware that comes with the aircraft, just because they are not self-tapping screws. So you really have to create that thread in that plastic as best as you can. I usually put a ton of pressure between the parts and the original hardware, which was not a lot of fun, but I made it work. But after finding these screw sets online, it just made it that much easier. You don't have to over tighten these at all. It just once the screw stops, you're pretty much set to go. All right, let's start with this. Goodness gracious, screws are so tiny. I don't really have a mat here, so once they drop on the ground, I'm gonna have to pause the video and try to find it again, but hopefully that's not the case. So all right. Now, as far as printing these parts though, printing them in PLA versus PETG, you could print them in any material you want, but the second summer comes around, PLA tends to deform in the heat very easily, which is why I highly recommend using PETG, because the heat does not affect these parts as much when if you're out in the field pretty much and you wanted to have the helicopter just sit outside. That is one thing that I would be worried about, is if your goose guy's outside and you're just waiting for your batteries to charge, or you're just sitting outdoors, and then before you know it, your Goosky S2 is just, completely deformed, and then you're gonna have to go back home and 3D print new parts. But thankfully, PETG has a stronger resistance as far as deformation in the heat. So you have screws on the back here, screws in the front. You got the first part of the frame done. We'll do this second part. As I mentioned before, these screws that are going into the frame and the adapter on this side are M1.5 by 3s. And as mentioned before, I did try to do my best to make sure that these screws are the exact same size as the ones in the original kit as far as size goes. Oh. And I am using, once again, a pH 0. Alright, one more screw. And then the frames should be done. As far as, look at that. All right, maybe we can just put the, let's put this, let's start from the front here. Actually, believe it or not, I also realized that, here, I'll bring the helicopter in here. I did forget to print this front bracket, and as far as this goes, I had a little bit of supports on this when printing flat on the bottom of the bed, just because these are angled upward. So I'll probably end up taking this one off and putting it on here because I did forget to print that. But if you were wondering where that part is, it's actually on that helicopter, and it is my fault that I forgot to print them. All right, so for the flight controller tray, these are the longer screws because that's, you might not actually have to use the longer screws for the flight controller tray. I use them specifically because they were long on the original frames, but that was because you have the front bracket that sits here, as well as this metal piece that comes around. It's maybe a frame enhancer. It's like a metal part, so it thickened up the frames by a little bit. If you look at the original helicopter, that's pretty much why these screws were a tad longer. So you could probably get away with making these screws a lot shorter. And this set, as far as this screwdriver, this Strabito set, comes in handy. The reason I recommend it is usually when you're screwing Phillips screws, if you're using standard screwdrivers you get at a hardware store, they'll work, but if you don't have the correct size and you're just trying to put in the screws in, you might start stripping out the head, and you definitely don't want to do that. And the set itself actually comes in handy with multiple different applications, but I specifically bought mine for this aircraft. Awesome. What's crazy is that these frames are so flexible, but the second you start putting in all these components, it really starts to stiffen up these frames. But I mean, hey, it's not carbon fiber. They are plastic frames. I'm not expecting them to be extremely rigid. They have been flying decently well for me, so no complaints there. But this airframe, I'm hoping to fly this airframe a lot harder than the videos I've been posting. I know it would be great content to make this thing absolutely explode in the air. I think it would be funny, actually, but I still want to be doing some testing before absolutely annihilating this thing in the air. But I will also have a few other pilots test fly this airframe, and hopefully by IRCHA we can have a few pilots fly this airframe, or hopefully we can see some pilots at IRCHA already with their Goosky completely converted. But it is a very good beginner friendly sport flyer. If you're not planning on flying it too hard, you won't notice a difference. This is specifically, if you're flying extremely hard like those professional pilots, yeah, it might, you know, tail boom might flex enough where it might hit the blades might hit the tail boom, and you know. But as far as just a friendly beginner flyer, not too bad. So we have the battery tray here. We'll pop this in here, and the battery tray, I believe, is, let's check, M1.5 by 4s. So we'll be using that. Let's just pick one here. Oh, it's really nice about this screwdriver. It's like partially magnetic. Actually, I tend to like to put the screw into the frame just a hair so it sits there, and then it's a lot easier to assemble the parts. See? Then they sit, you put the part in, and then you just screw each side in without any problems. See? Carbon fiber, you can't do that. But easeability can be nice. I am very curious on people posting this airframe of this goose guy all over online. Kind of curious on people's reactions. I only have so much time during the day to test this out, but I'm hoping that we can start printing some of these airframes or these helicopters more often, because it definitely makes flying a helicopter a lot more affordable. Then again, the Goosky S2 is affordable already, but to bring down the price of your parts as far as cost goes by about 10x, almost more than 10x, but close to 10x, can be substantial. And without having to worry about, you know, crashing, that's a pretty big deal. Now, as far as this motor mount goes, this extruded area should be pointed upward, and it should be assembled just like that. But as mentioned before, let's put the screws in first. And these are the same M1.5 by 4 millimeter screws that you're going to be using. So put them on the side. First, and then it'll just hold. But my most recent video of me crashing, man, at first I was a little thrown off because I thought I was flying for a short period of time. Then I crashed the skids, and then I thought to myself, well, that's not going to cost me much, and plus I don't have to wait for parts to be shipped out to me. I have a printer. You know, anytime you crash, you have parts available 24/7. And not only that, these things don't print too long. I'm not sure how long. I'll probably go through a separate video as when it comes to the specific settings I use on the slicer. So there's a program that you use called a slicer to set up your print settings, and I'll definitely go through that video or make a video on how to print these parts and have it in the settings that you want. I'm currently using a Prusa slicer. I used to use Cura, but I have a few friends that use Prusa and they really do enjoy it. And when I was learning 3D printing, I needed to use a software that they were comfortable with and they knew the settings. So that's why I stuck with Prusa, but I cannot complain. It's definitely a good slicer. Now, wow, this helicopter's coming in a lot faster than I thought. Now, let's see. Let's put the boom block. Actually, I keep forgetting I'm constantly wanting to put the part in, but it's so much better just to put the screws into the, oh, well, I guess frame holes are so open that they just slid right in. So if it's the same thing, yeah, these, oh, almost dropped that one. That would have been bad. Well, you know what? I'm just gonna flex the frame outward. There we go. Now it's all set. All right. Now, so yeah, you really don't have to over tighten these, and the best part about assembling these plastic components together is, guess what? You do not need any Loctite. So the second you screw these suckers in, you're set. You just gotta observe them, make sure that they're staying in their spot, but most of the time self-tapping screws do a pretty good job at staying in place. That is also a very nice benefit. All right, let's put the, you know what? I'll put these bottom screws in later. Actually, I could at least put the right side. I believe they're the right side. Yeah, the right side. So the right side of the boom block and the left, these big screws right here, they use a PH1 Phillips screw head. So this is mostly to hold the block. Awesome. Oh. Perfect. Now we'll put these M2x12s in a sec, but I think we'll do the skids last because I actually forgot my lighter, so I'll have to pause the video and get that. But all right, let's do the anti-rotation bracket, which I'm already putting it on wrong. It's should be facing like this. The funny story is you actually do not need to use the screws from that screw kit for this anti-rotation bracket because the one that comes with the kit already has self-tapping screws. But you know, to match all these, gotta make it fun. So the, let's see, anti-rotation bracket is a M1.7x6, which are these. So let's put this on here. Perfect. So that is holding in place very nicely. Kind of right, 1, 2, 3. Did I forget a screw? Huh. I wonder why we have an extra screw right here. So that one's for the battery tray, which we have. The motor mount. Top left, right boom block. Huh. Interesting. That's gonna throw me off why we have a spare screw right there, but maybe I'll go down this video watching it later and hit my head against the wall thinking I did something wrong, but that's okay. It was 1, 2, 3, 4, and then you got 3 and 3, 2 and 2, 2 and 2 here. Okay, anyways, let's just move on. I'm not gonna make you guys wait, so here we are. but I do recommend these screws. They make assembly much easier. I did try to replicate these parts as similar to the original parts, but for example, the tail boom block couldn't look like a skeleton because I needed some material and it would be extremely weak if it had the original aluminum block. So, all right, so let's put this one off to the side for the time being. And let's put together the tail boom. All right, so make sure that this hole is facing upward, and then we want to put the vertical stabilizer like that. Vertical stabilizer uses a M1.5 by 5. So 1, 2, 3, 4. So those are these screws. Oh, well, that would make sense because I need a pH 0. There we go. So I tend to put these in first, and then just enough where the top of the screw or the bottom of the screw is piercing out. There we go. Now you use those screws to kind of find the holes. Once they're kind of set in place. Oh, sorry, I'm off video, didn't realize it. Sorry about that. So once you guys find it, it's not really moving. That's when you know you're kind of set in place and you just screw them in, no problem. Oh, also, one thing I did want to mention that I haven't mentioned in any of my videos yet is that the original weight for this Goosky S2 with a battery is with battery is 345 grams. I've actually measured out, I'm gonna pull this back in here. I measured out this entire this entire S2 with a battery in, and I actually sheared off 6 grams. So if you guys are curious, it weighs about 239 grams with battery. So it actually weighs 6 grams less, if any of you were so curious. Oh, that's why. I knew I'd figure that out eventually. The screw that was still in that tray was for this top screw. There you go. Just got to make sure that the hole of the tail boom lines up with the hole of the tail boom block. Man, I thought I was gonna go crazy trying to figure that out, but I'm sure you guys watching me freak out already knew. So there's your set screw. Yeah, it's gonna be hard to see it on video. Kind of hard to see on video, but it had the tail boom isn't tightened up yet. This is where you really want to remember pH 1 for the M2s. So this is where you could take the long screw, and this is where I don't really mind tightening or screwing this in a little tighter than usual, because the whole point of this is to make sure that the tail boom block is really tightening up on that tail boom as much as possible. So before I do that, let's just put these in. Alright, I'm going to see if I could flip it around. Maybe we'll be able to see the tightening, I'm not sure. But you could see the screw is already through. I'm not sure if you'll be able to see the tightening, but I don't want to over tighten it. But I've tightened it quite a bit. So now that definitely will not budge. Okay, last thing to do is to put these landing skids on. But before we put those on, I'm going to put this off to the side. Before we put these on, we need to form them. So I'm going to pause this video really quick, get a lighter, put this off to the side, get a lighter. I pretty much heat up this corner a little further from the actual area where the screw goes into, more like around here. Heat it up on both ends and just slowly start bending it to place. So bear with me. All right, I'm back with a lighter. I don't know how well this is gonna look on video, but let's try it. I've done a few of these already, so I have a rough idea. I'll just slowly bend it to shape. Then you kind of hold it there a little bit. I'll hold it. You will have this black discoloration here, but that's perfectly fine. There you go. That doesn't seem too bad, right? So I've learned, I used to do this one at a time, but the best way to do it is to heat it up in both areas. Not for too long. You could kind of look at the timestamp of this video to see how long I was heating it up, and then you just slowly bend it, and then you pretty much are set. So let's try to do the same thing on this side. You want to do your best to make sure the angle is quite similar. If it's not a big deal. The whole purpose of this part is to just keep your helicopter off the ground. So it does not have to be perfect, but with a certain amount of times of, there you go. There you go, landing skids within a matter of, I don't know, 30 seconds. I didn't really time that, but anyways, there's your landing skids, just using a simple basic lighter, heating up the corners. Now that you have all these set, let's go back to assembly. You just pop these in. You know what? I've mentioned it so many times in the video, but I don't seem to learn. All right, screws on first. It's just easier that way. Not even too much, just a hair. Okay. Do that on all 4 through holes. Kind of stabbed myself on that one, jeez. Okay, almost there. There we go. By the way, if there are basic parts or components that you need, I did not design this, could have designed it, but I actually scaled it down by about 50%, so it was much smaller. That tray is quite useful. Once you get into 3D printing, all you could think about is 3D printing. And all the parts and components you could replace and fix and engineer. Goodness, last screw, so I'll just pop it out. It's quite fun, actually. Fun hobby. Extremely nice because a lot of engineers and designers, there are parts that you can buy, but some parts, or pretty much all parts, are free. So, all right, let's put these in. Flex the frame just a tad bit. There we go. Awesome. Let's start off with this side. Not too tight, but just enough. I'm doing my best to keep this on camera. Sorry, guys. I've been trying to focus in on the camera view. Let's see here. Oh, I already did that side. Let's do this side. All right. The holes weren't fully aligned, so I have to pop that out. All right. Now we should be good. Awesome. Last screw. Perfect. And there you have it. A full-blown assembled PTG plastic Goosky S2.